Have you ever wondered which weight of BB you should use to dominate the airsoft field? Hi, I'm Rebecca, and we're going to answer that question on today's episode of What the Tech. One of the crucial components to dominating the airsoft field is time to target. A shorter time to target is vital because the longer travel time will allow your target to move and avoid the shot. It has been well documented that a heavier BB will be more accurate, but conventional wisdom says that the downside to the heavier BB is a longer time to target. However, recent experiments have called this conventional wisdom into question. In our experiment, we used two different weights of BB, .25, which is the lighter BB, and .45, which is the heavier BB. To avoid having more than one variable, we had to account for a counterintuitive phenomenon known as joule creep. Joule creep occurs when a heavier and lighter BB are fired at the same pressure, which typically causes the heavier BB to be fired at a higher energy level than the lighter BB. This correlates with Newton's second law of motion, which is force equals mass times acceleration. To eliminate joule creep, the MTW's pressure was set so that both BBs were fired at the same energy of 1.5 joules. Secondly, drag plays a huge role because as the BB flies through the air, the force of the air resisting the BB creates drag. This is vitally important because different weights of BB with the same shape and size have different amounts of drag because of the drag equation. The only variable in the drag equation that changes between our two BBs is the BB velocity. Everything else is identical. When a lighter BB exits the barrel, it has a speed of almost 100 feet per second faster than the heavier BB. This means the lighter BB has exponentially more drag working on it. Thus, I hypothesized that when a .25 gram BB and a .45 gram BB are fired at 1.5 joules at some distance, the heavier BB will arrive at the target before the lighter BB.
All right, this is .25s at 10 meters.
We tested each weight of BB at 10-meter increments using a metal target while recording with a phone. We collected 4 data points at each distance by shooting and hitting the target 4 times. We visually analyzed the recorded sound with audio software looking at the wave beats.
All right, this is .25s at 10 meters.
The first peak is from the gun firing. The second is the BB impacting the metal target. Using Excel for further data analysis, we calculated 3 of the 4 shots to create an average time to target. Then we calculated the difference between the lighter BB and the heavier BB. This gave us the difference in time to target between the two. Using that difference on an XY scatter plot where X is the distance in meters to the target and Y is the difference in arrival in milliseconds. We then performed a polynomial fit to get an equation which we solved using the quadratic equation to find the point at which the BBs will arrive simultaneously. We found that at exactly 36.7 meters, the BBs will arrive simultaneously. If you look at the graph, if the number is positive, the lighter BB will arrive first, as you can see in these 3 data points. But if the difference is negative, the heavier BB will arrive first, as you can see in these 2 data points. And right here is 36.7 meters where they hit at exactly the same point. These distances are well within the standard ranges at which airsoft engagements happen. The results support our hypothesis that lighter BBs reach the target first is at least overly simplistic. Well guys, thanks for watching, and I hope you learned something and these results help you, and we'll see you out on the field.